You use it every day. Streaming, messaging, browsing. But how does the internet actually work? Where does data go? How does it find you? The answer is physical. Cables, routers, servers, data centers, across the planet, connected like a nervous system. It starts with your device, phone, computer, tablet, connects via Wi-Fi, cellular, or Ethernet, to a router, your gateway, with an IP address, a unique identifier, like a home address. From your router, data travels to your ISP, Comcast, AT&T, Verizon. They have fiber, copper, cell towers. Your data enters their network, then travels onward. How does it know the way? Routing. Every device has an IP address. Numbers like 192.168.1.1. This tells networks where to send data, like postal mail. But data breaks into packets, small chunks, each with origin, destination, order info. Packets travel independently, taking different paths, like friends driving to the same party. Different routes, same destination. Routers read addresses at every junction. Choose the best path. Forward packets, hundreds of hops. In milliseconds, paths depend on congestion, quality, distance, cost. Routers pick the fastest route. Now undersea cables. Most traffic travels here. Not satellites. Cables on the ocean floor. Hundreds connect continents. Carry 99% of international data. Fiber optic. Glass threads. Light carries data near light speed. Owned by Google, Meta, Microsoft, telecoms. Billions invested. Because data is valuable. New York to London. Under the Atlantic. Less than 100 milliseconds. Satellites are slower. Higher latency. Fiber is faster. Reliable. Cheaper. Servers host websites. Not concepts. Computers somewhere. Storing files. Images. Code. You request. Server sends. Browser displays. Servers live in data centers. Massive buildings. Computers. Cooling. Power backups. Security. Running 24/7. Google. Amazon. Microsoft. Data centers worldwide. For fast access. Content delivery networks. CDN. Copies stored in multiple locations. You get data from the nearest server. Faster. Efficient. Protocols govern communication. TCP/IP. Transmission control. Internet protocol. TCP ensures complete. Ordered delivery. Retries lost packets. IP handles addressing. Getting packets to the right place. Together they form the Internet Foundation. HTTP for websites. HTTPS encrypted. FTP for files. SMTP for email. DNS translates names to addresses. You type google.com. DNS finds the IP. Without DNS you would memorize numbers. DNS is the Internet Phonebook. Distributed. Redundant. Reliable. The backbone. High-capacity fiber. Connecting major networks. Internet exchange points. Where networks meet. Exchange traffic. Physical buildings. New York. London. Tokyo. Frankfurt. One connection. Many networks. Efficient sharing. Who owns the Internet? No one. And everyone. Decentralized. No single entity controls it. ISPs own the last mile. Telecoms own long lines. Tech companies own servers. Cables. Data centers. Governments regulate locally, but cannot control the whole network. This makes the Internet resilient. Damage one part. Traffic reroutes. By design. Created during the Cold War. U.S. military. A network surviving attack. No central point. No single failure. Packet switching. Data finds another path. Genius design. Speed. Bandwidth. Data per second. Megabits. Gigabits. Your plan sets speed. 25. 100. 1000 megabits. Faster means smoother streaming. Quicker downloads. But speed varies. Congestion. Distance. Infrastructure quality. Peak hours. Rural areas. Slower. Fiber areas. Faster. Latency is delay. Sending to receiving. Milliseconds. Lower is better. Gaming needs low latency. Streaming tolerates more. Ping tests measure round-trip time. Under 50 milliseconds good. Over 100 noticeable lag. The future. 5G. Faster speeds. Lower latency. More connected devices. Internet of Things. Satellite Internet. Starlink. Beaming from space. For remote areas. Quantum Internet. Theoretical. Quantum mechanics. Unhackable. Ultra-fast. Experimental. But basics remain. Packets. Routers. Servers. Cables. The Internet is physical. Not magic. Engineering on a global scale. Next time you load a web page, remember the journey. Device. Router. ISP. Undersea cables. Exchange points. Servers. Back to you. Milliseconds. Invisible. Essential. Connecting you to the world.